let's talk about solving absolute value equations. So when we talk about absolute value, just as a reminder, that is a number's distance from zero. So it's how far away a number is from zero. It is always positive. Even if the number we're talking about is negative, the distance from zero is a positive number. So absolute value is always positive. Now let's talk about a few examples here. If the absolute value of if the absolute value of x is 5, what could x be? So we know the absolute value of some number equals 5. So we're looking for a number or numbers that are 5 spaces away from 0. And we know those numbers are either -5 or +5. So x here actually has two values. It could be -5, it could be 5. Now what about x plus 3? The absolute value of x plus 3 equals 5. So we know that x plus 3 is 5 spaces away from 0. Well, I want this in the absolute value here to be 5 or -5. We know that from this first example. So what I can do is think about those two situations. If x plus 3 has to be +5, I know that x could equal 2, because 2 plus 3 is 5. That's the easy one. But if I want that to equal -5, I want some number plus 3 to equal -5. Well, that's got to be -8. -8 plus 3 is -5, which is 5 spaces away from 0. So it kind of sets up these two cases. Now, how many solutions can an absolute value equation have? Typically, when you solve an absolute value equation, you will get one or two, usually two, or one solution. They can also have no solution depending on how the equation is written. But in this class, most of the time we will have one or two answers. So let's solve some examples here. Like we saw above, we have our first two. If the absolute value of x is 5, that means x can be -5 or +5. And if I check my answers, if I put them in here for x, the absolute value, which is this symbol here, of either one of those numbers is 5. Same thing for here, x plus 3 and the absolute value equal 5. We did that above. We get -8 and 2. And if I plug those both in, -8 plus 3 is -5. That checks out. 2 plus 3 is 5. That also checks out. Okay, example C, 2x plus 5 equals -5. Now, here is something to watch out for. This absolute value, whatever is in here, I'm looking at the absolute value of that, the distance from 0, and absolute value is always positive. So this can never equal -5. And so we have no solution here. There is no number for x that can make that equation true. All right, the absolute value of x plus 10 equals 8. So let me check this. This amount here in the absolute value has to either equal 8 or -8. And what I can do, instead of trying to visualize this in my head, I can write two equations. X plus 10 equals +8, and x plus 10 equals -8. Because that's what either of those cases have to be equal to. So if I subtract 10 here, I get x equals -2. And if I subtract 10 here, I get x equals -18. Now I should check both of these. -2 plus 10 is 8. The absolute value of 8 is 8. That works. -18 plus 10 is -8. The absolute value of negative 8 is 8. So both of these answers work out. So we can write two cases based on our equation to get our two responses. Lastly, or not lastly, but for this section, example E says the absolute value of 9x equals 81. Again, I can write my two cases. 9x has to equal 81, but it can also equal negative 81. So if I divide by 9, x is either going to equal 9 or negative 9. And both of those do work out. 9 times 9 is 81. 9 times negative 9 is negative 81. And both of those have an absolute value of 81. Let's keep going on some slightly more challenging ones. Now, we have a variable on both sides, but the concept is the same. Whatever's in the absolute value here is x minus 5 has to equal 2x plus 35 or negative 2x plus 35. So let's write those two cases. First, x minus 5 has to equal 2x plus 35. Or x minus 5 equals, now when you distribute a negative, you have to do it to both things. So it's going to be negative 2x minus 35. Make sure that negative sign gets distributed to both terms in that expression. So let's solve this. We'll subtract 2x and we'll add 5. So I get negative x equals 40. And so for this equation, x is going to equal negative 40. Over here, we're going to add 2x and add 5 just as before. But this time, I get 3x equals negative 30. So x equals negative 10. Now I need to check both of these answers in my equation. So negative 40, we've got to put it in for both x's, goes here and here. So here I get negative 45, but it's the absolute value, which is 45, equals negative 40 times 2 is negative 80 plus 35. So I end up with 45 equals negative 45, which is not true. So this doesn't work. So x cannot equal negative 40. Let's try negative 10. Negative 10 minus 5 is negative 15, but it's the absolute value, so that is positive 15. 2 times negative 10 is negative 20, plus 35 is 15. Maybe I should write that out. Negative 20 plus 35. There we go. So 15 does equal 15, which does work. So x equals negative 10 here, but not negative 40. So only one of those solutions worked. This is what's called an extraneous solution. And it often happens when you have variables on both sides of your equal sign. So something to watch out for. Let's go to example B. Again, we have lots going on. Now notice, up till now, our absolute values have all been alone on their side of the equation. Here we have other stuff going on. So before we can set up our two cases, we have to get this alone. We can't mess with it. We got to leave it the way it is. So first we're going to add x to both sides. But we'll also divide everything by 2. But I guess we'll do that in a second. So 2 absolute value of x plus 1 equals 4x minus 4. And now we need to divide everything by 2. So I end up with absolute value of x plus 1 equals 2x minus 2. And now I'm able to write my two cases. So x plus 1 equals 2x minus 2. But x plus 1 also needs to equal negative 2x plus 2. Right? Distribute that negative sign to both. Now let's solve. Here we will subtract 2x and subtract 1. And here we'll add 2x and subtract 1. Okay, so negative x equals negative 3, which means x equals 3. We get 3x equals 1, so x equals 1/3. Not the best outcome, but we'll see what happens. We're going to check our answers. So first, let's check x equals 3. Putting it in for all the x's. Now, I could put them into these original x's here, but assuming my work is correct, it will work just as well to put them into our answers here. So that's what we'll do because it is less work. Okay, so let's put in x equals 3. 3 plus 1 is 4, the absolute value of which is 4. Put in 3 for x here. 2 times 3 is 6 minus 2. And 4 does equal 6 minus 2. So x equals 3 works. Let's try 1/3. 1/3 plus 1 is 1 1/3. The absolute value of which is 1 1/3. No need to make a decimal. We can just leave it like that. Now 2 times 1/3 is 2/3 minus 2. Well, that's going to give me negative 1 1/3. And 1 1/3 does not equal negative 1 1/3. So this doesn't work. That's an extraneous solution. So just x equals 3 on that one. Let's try example C. Once again, we have to get our absolute value isolated. So first we'll add 2x. So 3x plus 3 equals 3 times the absolute value of 2x plus 2. Now you'll be tempted to distribute that 3 into that absolute value. You cannot do that. We must get the absolute value by itself. You can't distribute into it. We must isolate it. So we'll divide by 3. So x plus 1 equals the absolute value of 2x plus 2. Now we can write our two cases. Now I'm going to go ahead and flip-flop these. So first, 2x plus 2 has to equal x plus 1. But also, 2x plus 2 has to be equal to negative x minus 1. Right? Multiplied by negative 1. And now we can solve. So first we'll subtract x. We'll also subtract 2. Here we'll add x. We'll also subtract 2. So x equals negative 1. And 3x equals negative 3. So x equals negative 1. We end up with the same answer for both cases here, which is nice. We just have one thing to check. So let's check that. And again, we can just use our simplified equation to save ourselves some trouble. So negative 1 plus 1 is 0. And then on the other side, negative 2 plus 2 is 0. The absolute value of 0 is 0. So this works out really nicely. And this is why we got the same number, because both sides canceled out here. So that's why they're both negative 1. X equals negative 1. That is our only solution here. No extraneous solutions, but there was just one solution for this equation. Okay, finally, our final example here. Which of the following are solutions of 3 times the absolute value of 2x plus 1 is greater than or equal to 9? Now, there's two ways to go about a problem like this, and it really depends on the type of work you are willing to do. So what we can do is take each of these numbers, plug them in for x, and just see if it works out. And maybe this is something you can do in your head, Or we can solve this inequality, and then we can see which of these numbers matches the inequality. And that's what I'll say we should do here. So first, let's isolate by dividing by 3. And we end up with the absolute value of 2x plus 1 is greater than or equal to 3. And now we can write our two cases. Just be careful, we are working with an inequality here instead of just equations. So we know that 2x plus 1 must be greater than or equal to 3. We also know that 2x plus 1 must be greater than or equal to negative 3, but actually, since this is an inequality, don't forget when you multiply by negative 1 or get the kind of the opposite set, we have to flip that symbol. So it's going to be less than or equal to negative 3. And now we can solve these. So we'll subtract 1. 2x is greater than or equal to 2, which means x is greater than or equal to 1. And over here we'll subtract 1. 2x is less than or equal to negative 4, which means, so that means x must be less than or equal to negative 2. So here are my two inequalities that give me my range of solutions. Now if I check these numbers up here, since it is an inequality, let's see what happens. If I put 1 in, that's 3 over here in the absolute value, which is fine. And negative 2 gives me negative 3, which is also the absolute value there is 3 as well. So they both work out. We can be happy with these ranges. Now let's check our solutions on this side. We need these numbers to be either one of these, greater than or equal to 1, or less than or equal to negative 2. Well, negative 2 is less than or equal to negative 2. 0 does not work. 1/2 does not work. 5 is greater than or equal to 1. And negative 15 is less than or equal to negative 2. So my answers that work are negative 15, negative 2, and 5. Now we could also plug these numbers in to our equation and check each one. This is not as efficient because if I had a long list of solutions, 15, 20, 100 numbers, it would be difficult and time-consuming to check every single number. But if I solve the inequality, then I can just check the number against these solution sets and I can know right away. So there you have solving absolute value equations. Absolute value is the number's distance from 0. It is always positive. Now, when you're solving equations, there are typically 4 steps to keep in mind. We've just gone through them, but just to recap, the first step is to isolate the absolute value. Get it by itself. Next, we have to write our two cases. One positive, one negative. Third step is just to solve both equations. And finally, check both solutions. You want to make sure you don't have any extraneous solutions. So those are the 4 steps, 4 basic steps for solving any absolute value equation. Isolate the absolute value, write your two cases, solve your two cases, check your solutions.